Thank you all the attendees for joining us today. I hope you all had a great time networking. We are now live. Good afternoon, everyone. Thank you for all the attendees to joining us today. Very good afternoon to you all. I, Sakshi, welcome you on behalf of Solar Quarter and First View Group to our webinar on choosing best solar inverters for utility solar system. So before starting for today, I would like to take this opportunity to thank and welcome our partner for this event, SunGrow. We have a short video of our partner SunGrow. I would request my team to start playing the video.
We are the first supplier to launch world's first biggest rating in terms of string inverter, that is a 250 HX that was giving 250 kilowatt active power.
We are coming up with this 10 gigawatt setup, which is going to have the SMT line manufacturing. So it means all the PCBs which we are using in our inverter is going to manufacture locally.
With the new factory that we have in place in Bangalore is going to bring this concept vocal for local.
This is a clean room concept with the ASD flooring. This clean room concept is used to manufacture the string inverter assembly. This string inverter assembly has got a n number of stages. Few stages will be used to assemble the inverter and another few stages will be used to quality control, production inspection and testing. This is the aging room. This aging room is used to perform the heat run test for the string inverter. Whatever we are manufacturing, 100% inverter will be tested in this chamber. Due to this, we can meet the customer OTD. OTD means on-time delivery can be met for the customer very easily, and we can deliver a very good and quality-oriented product to the customers.
SunGrow has done almost $16 million investment in India, which clearly demonstrates that our presence in India is for long. That promotes customer confidence. Also, the leadership in India has been given with good authority to take the decisions. So that is the best part in SunGrow India, where the leaders enjoy to take the drive and also deliver to the customer.
And now, without any further ado, we would start our much awaited panel discussion. Before that, we will be starting with a sponsor presentation by Mr. Pratik Sharma from SunGrow. Welcome on screen, sir.
Thank you, Sakshi, and thank you everyone for giving me the opportunity. Let me just share my screen. Hope my screen is visible to everyone. Sakshi, my screen is visible, right?
Yes, sir.
Yes, it is visible.
Yeah. So I hope you are aware about SunGrow because we are there in this industry from last 25 years across the globe, and in India since 2016 onwards we are here. So let me just go through quickly with the presentation. We are the most bankable inverter brand from last 3 years consecutively, as per the report Bloomberg, and the company and the culture. If I focus, then We have started, we have established in 1997, and the journey which we have gone through, as mentioned, that in 1997 the company has been established in China, and then the milestones, one by one milestones we have achieved in 2004, then 2009, and then company listed in 2011. Then we came to India. I mean, we have established our Indian factory in India in 2018, and we started the shipment from our India factory, and installation capacity of inverter equipment exceeded 100 gigawatt globally. That is in 2019, and in 2020 we won the China Industry Award. Sungrow's market value exceeds 100 billion RMB. In 2021, we ranked among the China top 500 ESG excellent enterprises. So this is the journey which we have came across since these years, and we are the ones still existing, but who has already crossed 25 years in renewable energy segment. Our company and culture is having some mission, vision, and values. The mission is clean power for all, which we want to provide, and our vision is very clear: to be the global leader of clean energy and in conversion technology. Of course, our values, which we are adhering: sincere and pragmatic, precise and open, and of course, the customer oriented. Then again, the verticals in which we are working across the globe, maybe some verticals are not there in India right now, but yes, these verticals are there in Sungo. That is PV inverters, which is a bread and butter for us. Renewable energy investment and development business. Basically, it's a IPP business. Then energy storage converter and system. This is ESS again, which we are working on, and it is available in India as well. And wind energy converter, it is there in China, and NEP division, it is also there in China. Floating PV system is also there in India and China both. And then smart operation and maintenance and electric vehicle charging equipment. Hopefully, in the coming time, we'll be coming up with this segment also to be added in Indian entity. An intelligent PV cleaning robot. This we have already introduced with the name of Sunpure in India, and renewable hydrogen production system. This vertical is also there, but right now it is in China only. Then PV inverter shipments ranked number one globally for consecutive 4 years, and number one nationally for 10 consecutive years. You can see the revenue total in million RMB. You can see from 2011 to 2021. You can see the growth from nowhere, from 0.87 to 4.57, then 8.89 in 2017, then 10.37 million RMB in 2018, then straight away to 24.14 million RMB in 2021. And if we see only the PV inverter shipment in terms of gigawatt, then in 2011 it was nowhere zero point 0.9 gigawatt. Then we moved to 8.9 gigawatt in 2015, then 16.5 gigawatt in 2017, and in 2021 itself is 47 gigawatt now, which we have done. Then we have our teams, which has been established, and we are spending a lot in R&D. As you can see from this chart, 40% of our employees are into R&D, and 13% are from management, and this 20% is from sales, and 20% and 27% is in the manufacturing unit. And the leading pattern of IPD, basically this is the process of launching any product or or a life cycle, basically you can say. uh, and this IPD makes it clear that product development is an investment behavior, which innovation based on marketing and asynchronous development pattern and reusable strategy. And basically it starts from market insight, then the market strategy and product and platform strategy, then project portfolio analysis, what all projects are there in the market, on based on which we can we can plan the product launching, basically. Then roadmap planning and chapter, then implementation and management of product roadmap. Then, of course, this here comes the complete uh, related to the product part. That concept, what would be the concept to launch the product, and what would be the plan, how to develop that product, how to maintain the quality, and when to launch that product, and life cycle, of course, to management. We have the world largest inverter factory. I can say inverter factory, 145 gigawatt per year global production capacity we have, out of which in China we have 120 gigawatt per year, and out of which energy storage is 6 gigawatt and 6 gigawatt hour per year. And then India factory we have, of course, scaled up to 10 gigawatt per year. And in Thailand also, we have come up with new factory. It is not mentioned here, but yes, we have come up with the new factory in Thailand also. That is 10 gigawatt again annually. And market and performance, basically the market expansion. First, we'll see Sungrow is the world most bankable inverter, as I've mentioned already, with over 269 gigawatt inverters installed across the globe as of June 2022, and Sungrow product power installations in over 150 countries and areas. The trademark of Sungrow has been registered in more than 160 countries and areas. These are few highlights of our plants. In one in India, and another one is also in India, Shambhupura. These are few references across the globe. 205 megawatt Fresco in USA, 130 megawatt in Algeria, 250 megawatt in India, 400 megawatt again in India. This 12.5 megawatt in Thailand, 500 megawatt China, 14.19 megawatt in Northern Ireland, UK. These are a few references. Then again, energy storage references, as I mentioned, it is a vertical which is there in India also, which we are doing, and we are looking for projects. So energy storage references are few wind and ESS project in Qinghai, and then 7 megawatt, 23.5 megawatt hour energy storage microgrid project. It's in Tibet. Then 150 volt DC coupling energy storage project in USA. Then again, one more in Japan. Now came to, if it comes to Sungrow India, then we started in 2014. Exactly, if I say, we started in 2014, and Sungrow entered India market for a 5 megawatt project in Badla, and we started that time through our channel partners. Then in 2015, first batch of central inverters came to India and installed in India, in Pokhran, Rajasthan, and since then it is running successfully. And in 2017, then we crossed 1 gigawatt shipment in India. In 2018, we established a 3 gigawatt local manufacturing facility in Bangalore. Then in 2019, we started export of made in India inverters to global market. And in 2022, we achieved a 5 gigawatt PV inverter shipment in India. In 2021, we achieved 11 gigawatt plus total shipment and expand local manufacturing unit to 10 gigawatt capacity in India. And if I say till now, we have already we have achieved 14 gigawatt of shipment in India. These are few market share as per the reports which we have seen in the market. In Q1 22, leading in inverter installation, 31% market share as per British India. In 2021, leading inverter supply, 34% market share. Then again in 2021, leading inverter installation, 33% market share. Then again in 2021, leading inverter supplier, 24% market share as per GMK report. In H1 2021, top inverter supplier, 21% market share. Then in Q4, leading inverter installation, 54% market share. Then in Q3 2021, leading inverter installation, 44% market share. Then in Q1 again, 2021, leading inverter installation, 31% market share. Then in 2020, leading inverter supplier, 24% market share as per Macom India research. As the numbers across India is growing, so we are also growing. And 2,900 days has been passed on, inverters are running successfully, and 14 gigawatt shipment crossed till date. If I say, then 40,000 plus inverters supplied across India, and we have a presence in 25 plus states. We have local team members of 400 plus, that is including our facility. And India's largest factory, first installed in India from Sungrow outside China, that is 10 gigawatt per year production capacity, having this much of capacity. And then if I comes to the product range, then we have the string inverters available with us, that is SG320HX, and earlier we were having this SG250HX also. And in central inverters, we have this 3125 rating, which we introduced to the market. Now we have recently launched this 1.1 into X series X model of inverter, which is a modular design, completely outdoor. And in residential segment also, we have a presence for in single phase and three phase also, starting from 3 kilowatt to 10 kilowatt and up to 20 kilowatt. We have several ratings. This is basically a showcase which we have shown, which I think which everybody knows. India factory achievement since 2018, since the day we established this factory. So 15.5 gigawatt plus shipments has been shipped from this factory, including the export also. And 16,000 plus inverters has been manufactured for India and overseas. And made in India inverters for local and global market, 30 plus models we have available, and 350 plus local job creations as of now. We have a wide service network across India. You can see in almost in every states wherever PV installed, we have our local person and warehouses, either directly through Sungrow or either through our channel partners. We have 35 plus local service team and 10 plus warehouses and repair centers across India. And we, as we always say, that we believe in always meet your demands for PV plant, and meeting the demand for that we have a wide range of products, that is SG 5000 UD-20, SG 3125, that is again central inverters, dash 31 dash 32, two models are there. This is again a central inverter. Then again, as I mentioned, the new model we have introduced SG 1100 UD-20, that is into 4, that is 1 plus X series basically. And in string inverters, we introduced this largest inverter till now, that is SG320HX. And earlier it was SG320, SG250HX dash in and dash 22 models were there. In CNI segment, we have this SG110CX and SG33 and 50 kilowatt in CNI segment. And soonly we are going to introduce one more friend of this in this family. So that is soonly going to launch, possibly in this REI. And in residential segment, we have this rating 5 kilowatt, 6 kilowatt, 8 kilowatt RT series, and 10 kilowatt and 12 kilowatt RT series. Then again, in higher segment, about 10 megawatt, we have this 15 and 20 also available with us. For monitoring segment, for all above inverters and for PV plant, we have iSolar Cloud, we have Commandant AAD, and mobile apps we have. And for Wi-Fi 6 also, we have this IM4 and Wi-Fi 6 available. And this is another vertical which we have added in our business part, that is SunPure, that is a robotic cleaning basically. So these are the type of robotic cleaning systems we have, that is PR100 fully automatic rail robot, then PRS100 shuttle system, then PS100 semi-automatic rail robot, and PT100 trackless robot. This is in energy segment also, we have a wide range of product, and these are the standard products which we are offering to the market as a complete solution. Uh, that is started from ST73 slash 159 kilowatt hour and 50 HV, and then again ST101 CP 50 HV, and then ST3340 kilowatt hour to 3150 UD. This is again a complete solution. Then it will go up to 3727 kilowatt hour to 1250 HV. This is again come with a complete solution. Then yes, battery, we have a LFP battery available with us, CATL in EV or others we are working with. And battery racks, of course, we are doing in our factory only. And containerization also we are doing in our factory only. And this is available with 0.25C to 2C. In PCS and DC to DC converter, we have a wide range, as you can see here, from 50, 60, 75 HV to 2500 UD series. Then we have Then we have the SD 125 HV, then SD 1250 HV. And for monitoring system, for all our system, that is we have EMS, local controller, Insight, iSolar Cloud, everything we have. Then, as I mentioned, new vertical has been added, that is SunPure, a robotic cleaning system. Then intelligent PV cleaning robot solutions compatible with various type of PV modules have been proven to significantly improve the power generation for PV plant. You can see the intelligent communication through 4G Wi-Fi optical fiber, and it is available. And robot management system and mobile application and iSolar Cloud. These are the compatibility systems which we have shown. For utility scale solution for hilly terrain, we always say that whenever undulation is there, that these inverters we have for your utility scale project SG320HX and SG250-N model. This is available as a string inverter. And in central inverter, when land is flat, yes, of course, this would be very beneficial. This SG5000 UT-20 and SG3125 HV-31 and 32. Then SG3300 and 4400-20. That is actually a OnePlus X series modular design which we recently launched. In C&I segment, as I mentioned earlier, these are the two models we have: 100 kilowatt and 33 and 50 kilowatt, and one more model is going to add in this family soonly. In residential segment also we are available, as I mentioned earlier, and shown the product also. Then again, the products available for India market. These are the products. These are few awards and certifications we have available with us. That is certificate of appreciation by Solar Quarter. Then again, this solar retail award we have available. In Maharashtra state specifically, we won in 2021, 20 and 2021, and that is by EQ. And in Rajasthan also we won this award through EQ. And again, a few more awards we have, that India National Annual Solar Awards 2022, and Business Innovation Conference and Awards. Most innovative solar energy product, basically, that has gone to OnePlus X inverter, Central Inverter. And these are the awards which were shown earlier also, Maharashtra State Award and all. These are few Sungrow has won few leadership award, and that has gone to our channel sales. Mr. Rajan is there, certificate of achievement basically, and then again this award we have certificate of achievement for state market leadership award for utility scale, and in C&I segment also we won this award. These are few activities which we used to do every time to to engage our employees and through activities in Sungrow. And at Sungrow India have a diversity in thinking and inclusiveness in results to make a winning team. That is go on. Then CSR activity also we are involved with, in which we used to plant a number of trees across India, and wherever our plants is solar plant, our inverter is installed. So nearby locations we used to install. We used to grow these plants and watch them growing and contribute to the India to be a greener. And Sankalp India holds a hand with this Sankalp Patu Foundation for this activity to paint different state of India green by planting trees in the lands of our farmer beneficiaries, civilizing their sources of livelihood, and also contribute towards the Green India and Clean India initiative. And some of Sungo esteemed customers who joined hands in this activity is Adani, LNB, Juniper, Aditya Green, and many more. These are few reputed clients we have available with us, with which we are doing business, and with which we already did business. There's Adani, Renew, O2, Azure, Amaraja, LNB, Sterling, Hero, Acme, Ford Partner, Ayana, Radiance, Greenco, Mahindra, Sustain, JSW, AM Solar, SunSource, Jackson, JBM, Avada, Raise, G Cement, and इसके तहत NTPC से की Bharat Petroleum, BHEL, Indian Oil, SGVNL. So that's it for the presentation. Thank you everyone for showing the patience and watching this presentation.
Thank you so much for that insightful presentation and for setting the
Sure,
tone for
thank
the
you.
event. Now it's time to begin with our much awaited panel discussion on choosing best solar inverters for utility solar systems. And to discuss this, we have on the panel with us Mr. Gautam Samanta, who's our moderator, Mr. Atul Pachori from O2 Power, Mr. Amit Kumar Mittal from Radiance Renewables, Mr. Rajesh Tiwari from Hero Future Energies, Mr. Syed Naqvi from Acme Group, and of course Mr. Pratik Sharma from Sun Group. I welcome all panelists on the screen and request Mr. Gautam to lead the discussion. Before that, I would also like to make a small announcement here requesting all the attendees to post their queries and questions in the Q&A box. Our panelists will take those after the session is done. Please, Mr. Samantha, you can take ahead. Just a moment, attendees. Mr. Samantha, can you hear us?
No, Sakshi, I think he was telling about the network. So I think due to network issue, he's left out.
Just a moment, attendees. Mr. Tiwari, if it's possible for you, you can take this ahead.
Fine, no problem. So we can either check once again or can. So thanks, Pratik, for a wonderful presentation. Uh, Basically, Sungrow is in this market having a strong presence, and one of the uh, we can say important role he is playing. uh, Basically, first of all, I would like to also thank to Solar Quarter for organizing such a wonderful event, and the topic itself is a very important nowadays, because solar inverter is one of the heart, as well as it is also one of the brain. So very important role it is playing in our solar power plant designing, as well as for the uh, meeting our target, which the very ambitious target which our Prime Minister has set for by 2030. Would like to look for having more than a 500 gigawatt, and I think by 2070 we are looking for the net zero. So inverter basically these are in typically days like earlier it was having a, uh independent system. So solar was somehow having a hybrid system which was connected with grid and battery, and some of the priorities were there. So on the basis of priority, if solar power is available, that was get it fed it to the load, and even that was charge the battery. And in case of cloudy weather, if autonomy is designed and batteries are designed accordingly, so load taken care by the batteries, or else priority change and this will go to the available grid. So somehow people were in mind that they can save the energy, they can save their electricity bill. But now looking forward, the coal crisis and the thermal power plant and other uh, carbon emitting power plants, those dependencies are not available. These are like they are not available for future. So we are now totally moving ahead on the dependency of the solar power plant or renewable energy, we can say. So in solar, inverter is there. In wind, there is a converter. And in similar way, wherever the DC power is generated, there we required a solar like conversion of AC. So basically, to begin with this today's topic, we have a panelist. I would request if all the panelists can one by one introduce themselves, and later on we will take topic as well. First of all, I would like to call Atulji. If Atulji can tell about like what their company do and what basically their role is. So we'll start.
Right.
Yeah.
Thank you, Rajeshji and Solar Quarter. So as we are losing time, so I'll be quick. I am Atul Pachori. I am representing O2 Power. I leads the operation department here, inclusive of hybrid, wind, solar, and sometimes green hydrogen also will be there. And we are the independent power producers. We are into we have developed some greenfield projects and also acquiring few existing solar PV power plants and wind plants in India.
Right. So thank you, Atulji. Said, if you can introduce yourself.
Yeah, thank you, Rajesh. So, my name is Sayed, right? I'm representing Acme Solar, right? So, we are also an independent power producer, right? As of now, we have a portfolio of about 6.5 gigawatts and for solar, and we're also now into green hydrogen and green fuels, right? So, for which we're also developing a project in Oman for about 5 gigawatts of solar.
Great, great. And we also have Amitji. Amitji, if you can introduce.
Yes, good afternoon, everyone. I am Amit Mittal. I am Executive Director Operations at Radiance Renewables. So, as many of you may be knowing, the Radiance Renewable is in the C&I market. So, we cater both renewable energy, wind as well as the solar. Currently, we have a operating portfolio of more than 300 megawatt, and another 250 megawatt is under a very advanced stage of development. So, I'm very happy to be part of this elite group and looking forward to a very useful discussion on the solar inverter, which is a very, very important component of the entire value chain. Thank you.
Great. So, and also like Pratik has introduced himself. Uh, Basically, I am. Let me start this thing. I'm working with Hero Future Energy as a assistant vice president, and I'm taking care for the solar grid utility design. Department. So there, basically from concept to commissioning, we can say, starting from the scratch and the ground label, and then complete charging and all things taken care by me. So there basically this inverter plays a very important role. In current scenario, if we see, uh, our first point was like the central inverter with large format, how it is like in the designing aspects with bifacial module and tracker system, how this is behaving, and which inverter basically we can say is much compatible. So uh, in case of like uh, bifacial as well as tracker, basically this all depend on the geographical ways. If your geography having like Pratik has told about undulation. So if you are nowadays like you are dealing with a big scale project, so there is a kind of 1.2 gigawatt single solar park, and in 1.2 gigawatt solar park, you required a huge amount of chunk. Basically, you can say something more than 4,500 acre. And in the 4,000 acre land, you have to maintain a complete, you can't be maintain the flat. So you have to see the cables, you have to see the designing of various type of modules to be get configured with your central inverter or string inverter, and the compatibility. So in this contest, I would like to ask from Said ji, basically what is basically their thought on this, how he is looking for the what is the challenge or any design compatibility with the central inverter and string inverters. So if you
Thank
can tell.
you, Adeshji. Thanks a lot for right. So, as a power developer, right? So our first and foremost aim is to optimize the power plant generation, right? And to achieve that, nowadays the manufacturers have helped us meet this, goal by producing bigger and bigger modules, right? These modules are produced in the same time, right, with higher wattage, requires less BOS, right, and so consequently leads to lower LCOEs. So that helps the purpose for us, right, in achieving this optimization of the power plant. But in doing so, what is happening as the current produced by these modules is directly proportional to the active area. So the larger the modules, higher would be the current, right, in these modules. And there lies the challenge, right, with the compatibility and adaptability of these new age inverters with these modules, right? So, for example, the DC side of an inverter, right, has a restriction to the amount of current that it could be connected with. So, if we talk about conventional string inverters, right, so this limit is set to about 12.5 amps, right? So, M6 module, 450 watt modules, connected string connected to this inverter under normal conditions, right, would not reach this or breach this limit of 12.5 amps. So there would not be any problem of adaptability, right? But when we transition into M10 and G12 modules, right, these modules produce currents up to the limits of about 16, 15 amps, right? And when we connect these module strings to these conventional inverters, they would be incompatibility, right? So if the input current is higher than the allowable limit for these inverters, there would be loss in conversion efficiencies of these inverters. So we need to be very careful when we are selecting these inverters, right, for our bigger modules, so that we don't lose out the advantage that we are getting in savings, right, by deploying these big inverters. So we need to be very careful that the current, right, maximum current limit matches the ISCs of these inverters, right? So for example, nowadays there are inverters available, I think Sungo as well, have 32 amps per string, right? That is the allowable current, which is compatible to all the new bigger sizes. So we need to be very careful, right, when we select these inverters, right, to these modules to enjoy the full benefit. I hope that you idea
Yes,
clear.
yes.
Hi,
So,
hi Rajesh.
yeah.
Good
Yes,
afternoon.
sir. Yeah. Yes.
Will
Sorry, yeah, sorry for my apology in
No
the
problem, sir.
connections because this is okay. So Syed, I think fantastic. I think y- can you introduce yourself? I know, I mean, you're working in
I
Acme, but yeah, but with your research work, particularly in the storage in the flywheel, so that will be giving a lot of weightage, for the others, right?
For sure, Mr. Samantha. Thanks a lot. So I did my master's right in Germany, and I was pursuing my PhD. So I was a research scholar there for 3 years, where I did. And the topic of my thesis was that I was designing, mechanical batteries systems, right, for roof-mounted PV, right. So those were flywheel energy storage systems which could run potentially for whole day, right, from solar and then give power back in the evening, right. So that was a research, and then I transitioned and joined Acme. It's been 6 years, so it's been quite a long time been working in Acme, and now I'm currently based out of Dubai. I'm working as a CTO Dubai in Acme now.
Oh, great. Congratulations. Thank you. So I think, nowadays, the large formats of the modules has come, So if you can share on the how it will be, from the developer's perspective, you can utilize, I mean,
That's what I was discussing, Gautam sir, previously with Rajesh ji,
yeah,
right?
yeah, 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 yeah.
But the current these modules produce are proportional to the size, right?
Yes.
So as we are having higher active areas, the current of these modules are increasing, right? So convention and so to handle these currents, right, we need to also have these new age inverters, which can, potentially adapt to these bigger modules. So, like previously, the inverter ratings were 12.5 amps per string, right, for string inverters, which were compatible to up to sizes of M6 450 watt peak, right? They can handle up to 12.5 in normal working conditions. But when you transition to M10 and G12 modules, the current rating goes beyond 15 amps or so, right? Especially in radiations where 800 watts per meter square. In those conditions, there would be a mismatch, right, in the maximum allowable input limit for these inverters, right, and hence they would not be able to handle the input power, right, and there would be more losses, right, and you would consequently lose the advantage that you're trying to get out of these bigger modules in the loss in efficiency of these inverters. So we need to be very careful when we are selecting these inverters. They need to be compatible and to the bigger sizes and should be very adaptable, right, to the challenges. And one thing I want to add on the part of the on the central inverters, right? As coming from the developer side, right? So our foremost aim always has been to achieve the lowest cost of electricities. And you, Mr. Samantha, having doing the same work, I understand the pressures that we guys have in giving up solutions so that the power or in during the bidding, right, process, the cost would be lower, right. So we need to tell our colleagues from the inverter industries to accelerate the research on higher voltages, right. As we are going on the bigger sizes of module, we are constricting ourselves to the number of modules in a string. So for M10, it is very difficult to connect 29 module strings, right? Because you would be going over 1500 during certain time of the year, right? Which the module guys would not allow. So I would like to see more research, more products coming up, right? Especially on the central and the string side, right? With higher voltages, right? Which would be compatible with the bigger module sizes available in the market. Samantha, you are on mute. Sorry, you're on mute.
Kindly switch on your mic, please.
Yeah.
I think, Syed, you might be knowing that today's even in the larger format of the modules have got different currents, as you have rightly mentioned, about the M10 and the M12. So M10 is a 13 ampere current, and M12 is a 17 ampere current. And now the new format has come is a rectangular cell with the modules, and where the wattage is 580 watt.
Correct.
Now,
Yes.
with the monofacial configurations, this is fine. But when we are talking about the bifacial modules, and when it has got an albedo with either in the fixed tilt and with the tracker system. So, can you share of your thought process that how it will be handled? Because the large current which is coming with a gain of maybe 10% and above. So
Sorry, Mr. Samantha, your voice broke up. I couldn't get for the last. Can you repeat, please?
Yes. So the last one is that uh, as the bifacial module with the monofacial, the current range is fine. But when it is either in the fixed tilt or either single axis trackers, and with a gain of 10 to 15%, so how the higher current to be handled with the inverters? So if you can share of
So
your thought process. Yes.
absolutely. So Mrs. Amanta, we need to have these margins built up in the inverters, right? So
Yes.
this this needs, when you are selecting the inverters or designing your system, right? You need to have these margins built up, right? To account for these gains, right? If you remember, before we have this bigger size of modules, one of the practices what the developers used to do to get higher yields was to overload the system by 50% on the poly modules, right? So
Right. Right.
overloading in India was about for 50%. So when we were selecting inverters at those times, we used to select inverters which were, guaranteeing derating at higher temperatures, accounting for this higher overloading. So similarly, when you are installing bifacial modules, right, on single axis tracker or the location where there's very good NPDO, so the chances are that you'll have an extra 10 to 15% energy gain, right, power gain, sorry. And then during that course of time, your inverter needs to be compatible to handling this kind of surge in energy.
Great. Great. Thank you, Said. Can I go next to Mr. Amit Mittalji? Can you introduce yourself? You are Executive Director of the
Yes.
Radiance Industry. Yes, and then
Yeah.
your experience. Please share it.
Yeah, actually, sir, I have already introduced myself. So just to repeat, I am Amit Mittal. I'm Executive Director Operations for Radiance Renewable, and uh, I'm handling the operations starting from the development of the park to the asset management of the commission project. So it's an end-to-end responsibility with me. So that's little brief about me, and I have got around 35 years of total industry experience, mainly in the power sector. Out of that, around 12 years in the renewable energy.
But nuclear to renewables, how the transition is,
Nuclear to renewable. So nuclear, thermal, CSP,
and also in the
and
journey
now
there was a
now
thin film
developing
modules, with the first
and
solar, right?
and now developing the wind power also.
Great. So I think with the latest configuration and the today's webinar is particularly on the choosing the best inverter for the utility scale. If you can share of your thought process from the
Yeah,
design perspectives, if it can be modular, how it can be, developed for the developers in terms of its flexibility and the different kind of the
yeah.
advantages. Yeah.
Yeah, I think what I would say, the recent development, especially last 1 year, these modular inverters are quite good from the developer perspective. Just to give a context, I was just recalling my early days way back in 2010 and 11 when we developed the first 40 megawatt project. That time we used zero point 0.5 megawatt inverters, and that itself was a modular inverter. Actually, it was 2.25 megawatt inverters clubbed together as a zero point 0.5. Industry has moved so much that whatever used to be the central inverter 10 years back, today we get even the string inverter of that particular sizes. Anyway, coming to the topic, I think the modular inverter is a very good flexibility provided to the developer. As most of us know that in India, land is a very tricky situation, and many times it happens that even if we get the land, the shape may not be the ideal for the project, and there are many restrictions that we cannot put the inverters of the maximum capacity to fit into our layout. There are a lot of constraints. Also, the C&I segment also, especially in the open access, it gives a very unique challenge that your projects, although your park can be of 100 megawatt, but the individual projects can be of the different sizes. Some can be as small as 5 to 10 megawatt, and some can be even larger. So this modular inverter give a very good flexibility to the developer, because practically what happens that depending upon your need, you can directly, it's more of a plug and play type of thing. So suppose it's in the 1.1 megawatt ratio, so you can have the inverter of 1.1 or 2.2 or 3.3 or even larger the things. So it gives a very good flexibility. Otherwise, what used to happen before this modular concept came, the company will have the different models, and then you have to choose, okay, I am buying few inverters of 5 megawatt, few inverters of 3.1 megawatt and other things. But this modular inverter has given a very good flexibility from the developer point of view. And that way, we, depending upon the requirement of the projects, depending upon the land shape, depending upon the my DC field requirement, i can I can have basically the same make of the inverter, the same type, rest of the components are same, but I can tailor made my overall inverter capacity to the my requirement. So this is I would say is a very good this things. And overall, if I would say that there has been a lot of improvement both in the central inverter as well as in the string inverter in terms of the technology upgrade, in terms of increasing the size of the inverter so that it becomes much more competitive on the LCOE basis. And also a lot of support also has come for the grid, because as more and more renewable energy is being pumped into the the grid stability is also very important. So some of the grid support features like LVRT, HVRT functionality, anti-islanding facilities, the nighttime reactive power compensation. These are all some of the very important features which come these days as a default with the inverters and help to improve the overall system design. Thank you.
Sir,
Sir, you are in a mute.
you're on mute.
Yes, something, Amitji, it is almost like a the block size designs and with the modular concepts. So that will be an
Yeah,
easy because AC block size, and then accordingly you can have your overloading with the DC. Right? So we will discuss
correct, correct,
at a
correct.
later stage. Next
Yeah,
I'll ask Pratik. I think Pratik, you are waiting. It's a nice presentations. And congratulations for 260 gigawatt level of global installations, and in India is a 15.5 gigawatt, which is equivalent to 5.7%, so almost 6% on the market share. If you look at the total
Thank you, sir. Thank you.
Indian installations on the solar, is something like 65 gigawatt, and if you see the global installations is almost like a terawatt. It's almost like a same numbers here on this thing. So,
Right.
can you share something about your the product portfolio? What we have already shown is fine, but in terms of the share of the 15.5 gigawatt, how much is the central share and how much is your string? This thing is inverter share. Yeah?
It would be somewhere 60-40 ratio. Basically, 60% is the central inverters and 40% is the string inverters. Currently, we are working on.
Okay, so in terms of the product range and the wattage, I mean, on the string inverter. So, what is the range? Because right from the not only in the utility scale but also in the rooftop applications, you have a huge range. So, what is the range that you?
So range we are catering in utility segment. Basically, we are having a string inverter of 295 kilowatt. Basically, SG320HX is the rating which we are having for utility segment in string inverters. And in central inverters, we are having this 1.1 into X modular design inverter, which we have recently launched to cater the requirement as per the requirement of the market, as the module sizes are continuously increasing, as mentioned by the panelist. And land parcels are also coming in a bigger patches, and gigawatt of projects are coming in a single batch. So considering all those things, we have launched this 1.1 into X modular design inverter, which is again because if you're selecting 4.4 megawatt of inverter, that is with 1.1 module each. So each module is 1.1, and four modules will be there. That is available with multiple MPPT to cater these requirements, and this is completely a outdoor central inverter. And in CNI segment, we are having this 100 kilowatt and 50 kilowatt and 33 kilowatt available with us. And soonly we are going to launch, possibly in this area, we are going to launch again a new edition in this family, and the rating will be disclosed by then. And we are available in the residential segment also, below to this year C&I. So in residential segment, we have this 3 kilowatt, 5 kilowatt, and then above 5 kilowatt, we have this 8, 6, 10, 12, 15, 20. This is the ratings we have in three phase. So all these products by which we are catering India market as of now. And of course, we are having another vertical that is into robotic cleaning. So that is basically with the robotic cleaning system we are having with the name of Sunpure. So that is again a new added vertical we have in India. And of course, energy storage segment, we are always available to cater the India market. We are having some standard solutions available, so that we are catering.
Okay,
We are
on the on the central inverter side, because now the new concept is that the quick commissioning. Do you have a containerized solution, 40 feet container that you can install there itself, with the
So we have already came up with the completely outdoor solutions now for utility segment in central inverters. As I mentioned, that 1.1 into X series is completely outdoor solutions, and that
okay,
is
okay.
not a containerized solution. Yes, and for containerized solution, yes, it is right now. It is not there in India market, not acceptable in the India market. I can say, but yes, outside India, there are containerized solution, that is MV solution, but that is completely different product. So that is available with Sungrow.
Okay, Pratik, are you available so that I can ask you, in the second round, some questions?
Yeah,
Is it
yeah.
okay? Yeah. Okay. Thank you.
Yeah,
Thank
yeah,
you.
you can ask.
Yeah. Thank you. Atulji, can you introduce yourself? I mean, sorry for waiting you long, and sorry for my disconnections as well. Can you introduce yourself? Then I'll ask you
No
questions.
problem, sir. So already done also, but again I'll do. I am Atul Pachori. I am representing O2 Power today, and O2 Power is an independent power producer. I leads the operations part here for all the renewable energy verticals.
Good. I think today is a very interesting topic to be the best solar inverter for the utility scale. And as a developers, yes, you also consult with your engineering team and you give the best input, because based on your previous and such a large experience on that, right? So there is always a pros and cons between central versus string, so if you can share of your thought process, what are the different benefits, the advantage and the disadvantage in both the cases.
Right. So always there is a debate whether to go with a central inverter or with a string inverter. So while choosing the string inverter, pros are many pros are there. Let's say I'll talk very practically. While installing any project, while we are commissioning any project, we know that first 2 months are very much volatile in nature. Many breakdowns are there which are not identified even. Okay, so many strings are not connected to the system due to maybe due to ground fault or the contractor is not connected. So with the central inverter, we may not be able to catch those breakdowns with whatever the best efforts we are having. So starting maybe first 60 days went off with almost 10 to 15% of the losses of energy due to these unaccounted breakdowns only, right? But once we have a string inverter, we can check those breakdowns on immediate basis and can rectify them with the help of ONMPD. So this is a very big thing which we can achieve through a string inverter, but cannot achieve through central inverter. Rather, even if we are having string monitoring, then also those establishing those string monitoring, connecting with those with the instrumentation system is a very long lead process for a solar plant because we work in a very haphazard manner at site because we got very little time frame for doing those things. So now when we are talking about the cons, so very little things are there, but yes, we always have to think about the grid compliances. Not only the LVRT and HVRT, few more compliances are there, just like P and Q requirements at the appropriate time. When we have to feed Q and we are connected to the state grid or to the central grid, yes, we have to feed the Q. So whatever the P and Q curve we have committed in our power sale agreement, we have to follow that, right? So even if it is 24 hours a day also. So in string inverters, while we are connected with the grid, we have to feed Q in the night also. It is quite possible we can feed the Q. But if in at any point of time we are disconnected from the grid, let's say due to any unscheduled or scheduled breakdown, after that until and unless we are having DC voltage available with us, so many of the string inverters are not capable in feeding the Q at night because Q can be required from the grid at any point of time. So this is only a con which I can see. Apart from the cost, which definitely everybody first of all everybody is segregating on LCOE part, then on the energy generation part, and then third these technical compliances part comes into picture. So yes, this is my view on string and central inverter. Central inverter definitely gives higher efficiency, a single place, everything is available, so that can be done in a better and efficient way. But in order to prevent those teething breakdowns for first few months, the string inverters are very much helpful in reducing those kinds of breakdown, and definitely 10 to 15% of the energy generation accounts a lot for large scale plants.
Absolutely, I think you're on the right track from the operation point and maintenance point of view. So the generations is very very important and with the less downtime. So in that, in case of any kind of a troubleshooting, I mean, if there is a couple of hours, if the central inverters is down, but sometimes if the some of the spare is not available, or maybe some fuses, small things, or maybe card, not at the initial stage, maybe after few years. But in that case, we know that so there are several string inverters which are available quickly in the stores, and you will replace it, and then you can do it within a couple of hours, and you have a dashboard, and where you can monitor. I mean, where is the find out where is the exact location that you have to do it. So. From the generations point of view, revenue generation point of view, yeah, you are on the right side, and you want to see that with the less downtime. We will discuss more on that. Rajesh, can you introduce yourself? Rajesh, are you there?
Yeah, yes, sir. Yes, sir. Very well.
Okay, great, great,
Yeah,
great.
thank you.
Introduce.
So,
And you are attending nowadays a lot of solar quarter, I think, webinars.
yeah, yeah. Yes, yes. So
Great.
thank you. Actually, thank you for Solar Quatra as well, sir,
Yeah.
for inviting us and having such a wonderful webinar. And this topic is really important because basically,
I'll come back
yeah,
because in the
yeah,
Hero Futures, I think you have
yes.
dedicated going with the string inverters. What is that? Why you want to
Uh,
go with the string inverters?
Let me introduce myself, sir.
Okay.
Basically, I am taking care of solar grid utility scale engineering.
Hmm.
And here I am as a assistant vice president. You can say in Karnataka in south started with 350 megawatt central inverters with SMA, and then we have don't to take name, but after that we have 450 megawatt, even more than that with a string inverter as well. Right? Yes.
Okay, I think you have a vast experience, right, from the value chain, the manufacturing to the developer installations and the operation maintenance. So
Right, sir.
share your thought process with the particularly with the string inverters, and with the new format, bifacial module, the tracker systems, how you are beneficial, for a developer, and choosing the right parameters. Those are very important.
Sure, sir. So basically, if we talk about particularly on the bifacial scenario, basically uh, when we have surface like backside gain, so we are having a approx we can say 10%, 12%, or 20%, depend on the albedo. So current gain will be there. So basically, the modules which are available, there are two type of modules. Basically, one is we can say having a higher voltage and lesser current, and one is having a lesser current and higher voltage. So the one same wattage, if you found in a 540 watt, you will have 17 ampere as well, and you will have 13 ampere as well. So in 13 ampere, there if you add the albedo gain, there will be hardly 15 ampere. So you are in the range of your you can able to do the use of y connector, and you can able to save your DC string cables. Uh, which is like 17 ampere modules, low voltage modules. There you will have add on the albedo gain, and you will reach to nearby 19 and 20 ampere. So there will be a difficulty. But so in the same time, module alteration I have to do. I have to design a single string. Uh, I have a limitation for the branch connector, but in same time Sungrow and now inverters manufacturers are offering more than 30 or even 30 ampere fuse as well. So there they have to take care for the limitation side, so that I can able to feed the uh, uh, power. There should not be any curtailment. in terms of tracker, this smart is string inverters, they are now coming up with the backtracking algorithm as well. So in their basically we can say diagnosis, so they have the algorithm. In the algorithm they basically do the analysis which string is not giving you the proper current. So the estimated current was there, and the actual current, and accordingly they, on the behavior of the basically trend of your whole day energy pattern, they suggest you that the particular string you need to set on the tilting or proper. So automatically there is a feedback mechanism in that your back road tracker will get adjusted, and that will save the shadow effect. So in the bifacial as well as in tracker, both ways, string inverter is one of the best way you can say. uh, yes.
And also minimize the mismatched losses from the rear
Yes.
side for the albedo, right? Okay.
Yes, so due
You
to multiple MPPT, that is one of the best way, and even the best part with the string inverter, you have a higher range of the MPPT voltage. So from
right.
starting 500 volt to 1500 volt. In center inverter, you will have something more than 750 volt to 1300. So narrow band of MPPT range. So you will not be able to wake up early morning and till late evening. So that is also
Yes,
one of.
yes. So the on the string inverters, there are at least 14 different advantages. The first is if there is a bypass diode failure, you can detect. If there is a PID kind of the losses, if there is a cracks in the cells, if there is a shadowing effect, if there is a swelling losses, if there is a high series resistance, if there is a current mismatch, if there is a low current output, if there is no current or the low short circuit current, and then the absolute, if there is a any kind of rapid power degradations, or the front glasses breakage, or any bar drop, or any broken ribbons. And also there are several features on that, and then there is an advantage on the DC cable side, as the string inverter is close, you don't need a string combiner boxes. Therefore you can save a little bit cost on this side, but you have to see on the AC side, because
Yes.
these AC side cables are costly. I'll come back very quickly. Amitji, we are discussing something like on a each block, block level, if you design your systems, and then first that one, and then the second one is that there is a always when we do an overloading, and then the clipping losses in particular the daytime, and how we can utilize it there with a hybrid or a kind of a storage systems. So both the things combined together, for the future applications, and then the RTC kind of a concept.
Yeah, I think you have touched upon a very important point, because typically what happens that to improve the overall plant efficiency, the overloading has gone right up to 50%. So like typically
Right.
1.5 DCAC ratio for the fixed tilt, and even with the tracker around 1.35 to 1.4 DCAC ratio is quite common. So typically
Correct.
what happens during the peak generation, during the daytime, at least couple of hours, in case of the fixed tilt, and few hours in the tracker also, you have to limit the power, because ultimately whatever is the AC capacity of the inverter, due to the grid limitation you are not supposed to inject more than that. So suppose like as an example, if my plant is a 100 megawatt, it's possible because of the high DCAC ratio I may be able to even produce 105 to 110 megawatt, but the grid will not allow me, so I have to curtail my inverter to 100 megawatt only. So in that case there is a lot of clipping loss happens. And depending upon the technology, we have seen that these clipping losses can be as high as up to 4 to 6% even in the first few years. Of course, as the degradation of the module takes place, these keeps coming down, and after 5 years they become quite insignificant. They become less than 1% or 1.5% after the end of 5 years. So yes, the one very important thing is that if we can have the battery storage, which can, instead of clipping the power, if I can store the that excess energy, then it can improve my overall efficiency. LCOE. In fact, we are working on couple of projects exactly on the same these things, that whatever is the clipped energy, we can store it, and then we can use it either to whenever there is a low power, we can give at that time, or maybe we can use it even for the peak shifting also. Only thing is, the limitation what it is coming is that although it looks very good theoretically, but when we put the economics still, it has got certain challenges, because the battery storage specifically has not
Very
come to the
expensive.
level what it was, yeah, what it was expected. So in fact, we looked two type of applications. One is this peak shaving, utilizing the clipped energy. Also, we also try to utilize another thing. For a power plant, I had to take the auxiliary power in the night, and most of the plants, the rule is that even if my PPA is at 2 rupee 50 paisa during the daytime, but in the night time I have to buy the power at 7 rupees, or at a much higher, that is a grid rate only. So we try to utilize that particular thing also, that if I can put a battery storage to take care of my auxiliary power, does it work for me on the NPV basis? But today what happens, that still the battery storage becomes little more expensive than the saving what we get. So it's not making a economical sense as of today, but I think it's only a matter of time. Maybe another couple of years we will have a different discussions, and it will be basically everyone will be using this particular
True,
technology.
true.
And
Appreciate.
it is
Yeah,
it
yeah.
is advisable also, instead of wasting the power, curtailing
It's
the
always
power.
to hand.
It's always good, yeah, it's always good if we can harvest this particular power and make good use of this particular power.
Thank you, Amitji. Atulji, can you share some of your thought process? Because now we are changing, from the system design 600 volt, then 1000 volt, now 1500 volt. Now going forward, we are working on the 2000 volt onwards. So from the developer's perspective, there is always a things that we talk about the LCOE, right? How to save the cost, but definitely at the same time it should be improved in the generations. It should, the efficiency of the inverter should be in such a way that it meet your requirement, and then finally the second the third questions, I on the warranty side I will ask a couple of questions, but can you share of your thought process on the higher voltage side, the future of system design, right?
Right, future of system design definitely, sir. Today, when we are talking about 1500 volt, which is the current philosophy what we are opting for, so if we are going for higher voltage, the modules in the definitely the series will be increased, and that will save some cost. But I'm not very sure that it will be a very considerable impact on some part, because as soon as we are improving, means increasing the voltage at
Mm.
the output end, then definitely all those the protection system and many other things will come into picture, right?
True,
So
true,
right
true,
now when we
absolutely.
are working on let's say a 1000 volt system, then cat 2 kind of a multimeter was okay. Now when we are working on 1500, then 1500 DC is quite impactful. So when we'll go for 2000 volt or maybe more, it will become more and more dangerous, right? And so protection system will also be designed according to that. So this is optimum level which every country is almost working on. So over and above
Yeah,
that, that will not much sense of it.
absolutely, you are correct. Because with the present configurations, like maybe 28 modules with a 1500 volt, and each one is having say 540 watt, and each module is having a weight of say maybe 34 kilos, right? So 34 into 20 is something like 1 ton, is the module weight, and the self weight of the structure is the 2 ton. At the static level, I mean, it doesn't matter, but in the dynamic load level, you have to think of
Mm.
when you are increasing with the 2000 volt, the number of modules may be increasing. Instead of 28, it may be 40, 42, right? So in that condition, the structured design has to be in such a way that it can withstand those are the important things. On the warranty side, and particularly on the servicing point of view, I mean, what are the things that you expect, like uh, some of the spare parts we should have with us, and then how quickly we can have the engineer to be in the place, or any kind of a warranty claim, and anything that you want to share something.
This is my favorite topic, I can say, warranty management, because
Yes.
when we are working on the new plants, let's say we are
Yes.
having some recent projects, we are working on the plants. So for the 5 years, things are very seamless, almost seamless, I can say. So we are calling to the inverter supplier, yes, he is coming very quickly because you have signed an SLA. Right, post 5 years, once the warranty is over, either to sign the extended warranty, let's say for 6 years to 10 years, then to 11 to 15 or to more at the award winning stage only, or if you have missed the train, then the journey will be very very painful. Okay,
Right,
so
right.
when we are saying about warranty management, it is really expensive affair after 5 years, especially for the inverters. So the people should be trained enough. The agencies, I know few third party agencies are also coming into picture that who are repairing those inverters, maybe ABB, Sungro or whomsoever inverters are there. But those are not the reliable practices, right? Because ultimately the cost of repair is much lesser when we are losing the generation, right?
True,
Even
true,
if
true.
we are having the insurance in place, okay, fine. So we have a BLOB or every insurance in place, but the 14 days time is also there. Then we cannot
Yeah,
claim the insurance generation also. So 14 days time versus the cost of repair versus the warranty cost is a very critical thing which we all have to analyze. So we will suggest, we are discussing with the key stakeholders in the market also, and also with the OEM, that how to manage these things, because this is not a practice that I will change my inverter after 5 years, or I'll run
true.
after the inverter OEM after 5 years. Or what we have
Right.
to do? Ultimately, the developers will be losing the generation, as many people are still, and definitely the energy, the green energy will not be going to the grid ultimately.
True, 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 true. So that the kind of forecasting what we have already given, those are the penalties it will. So it's a huge kind of a concern in areas. Basically, even if you see that you have a spare part, it doesn't work. Even if the maintenance engineers locally available and they can reach within say 8 hours or overnight. I mean, even then, if there is a fault, then we can go for warranty. Is the last things that you use it. Thank you very much. And then Rajesh. Uh, as we have seen that there are different kind of the quality norms. Quality means in terms of the IC, whether the efficiency of the testing of the inverters, and then the peak saving and the DC overloading, and then temperature operations, and a lot of other factors and this parameters. So which one you feel that from the inverter point of view these are critical? We should have a number one, two, three, four, that we should go with the kind of a most top rated item, so that we can will be in a positions like. So these are the parameters for the best choosing of the inverters, right?
Right, sir. So basically, in the front of IEC is basically there are safety guidelines, there are
Correct.
CPRI testing, and many guidelines which is released from the CA as well. So the important is one of the basically flicker test and harmonic measurement. Basically, if you are not able to feed the true sine wave, and
Right.
the quality of your output waveform is not accurate or as per the desired, like, because you have a reference voltage and
True.
you have a reference frequency, you have to somehow match, or either you have to be on the higher amplitude, so that you can able to feed and you can able to uh, uh, basically move into the transmission line. uh, this is the one of the important which I see IEC 61683, and also there are some IEC 62116 that is basically harmonics and waveform distortion. So these basically are important points.
Correct. Correct. Amit, one point. What is the key challenge is in terms of the procurement of the inverters? Amit ji, are you there?
Yeah. Yes. So,
Yeah, key challenges. Right. Yeah.
yeah, correct. So I'll tell you, the challenge starts with a very basic question, that should I go for the central inverter or should I go for the string inverter? The question starts from that itself.
Okay.
So one of the approach which we as well as the other developer also take is that we do the LCOE analysis for that particular project. Which type of module we are using? Are we using the bifacial or mono PERC? What is
Correct.
the
Current
are we
rating
using the
and
tracker and other things? And
voltage. Right.
based on that, because there are relative advantage of string inverter versus the uh, central inverter, and then we make a decision. Once we come to that particular decision, then of course there are few very very important thing in terms of the inverter selection. One is that, yes, the bankability of that, it should be a tier one, it should be a reputed make. Also, other parameters, that what is the efficiency, what is the uh, 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 basically the other features, especially the other features which like does it have the NTPID, does it have the reactive power compensation at night, what are the grid support functions. These are some of the very important parameters needs to be evaluated. Also one more very important thing is that the inverters do derate after certain temperature, especially above 40 degrees centigrade the inverter do derate. So the inverter has got a different capacity at 25 degrees centigrade and the different capacity at 50 degrees centigrade. So this is also one of the very important parameter, that what is the derating curve of the inverter, and we also match that what is the expected operating temperature of the site. So for that particular condition, which gives the most optimum uh, selection for the inverter.
True, true, true.
And
Absolutely.
as Atul
Yeah,
also
yeah.
has told, yeah, Atul also has told the another very important thing is the after sale service, because buying the inverter is a easy thing, but making sure that the required SLA is signed, the availability is being maintained. If there is any fault, it is attended at a very quick way, and how the response is there from the warranty from 6 year to 10 year and then 11 year to 15 year. That is a very important thing, because I have seen that at times there are situations that initial inverters are very cheap, but after 5 years we repent that it was not a right decision. So as Atul has told, I fully agree with that we do consider the extended warranty right up front, uh, agree on the numbers, and then that is one of the very important criteria while making a selection for the inverter.
True, true. So but there is challenge on the nowadays the Atmanirbhar Bharat. I mean, now it is domestically available, but otherwise the logistic
Yeah,
things in the cost also was more, and
yeah,
on the on-time delivery, then the commissioning warranty, then the BCD will be not now, maybe after some time it will be coming. Then foreign currency hedging. So a lot of factors, it will be there in for the
correct.
procurement. So, success. I mean, we are going to ask a few questions on the on already on the display or something.
So thank you very much, our esteemed panelists, for this wonderful session. And a very special thanks to you, sir, Mr. Gautam, for superbly managing the session. We will now proceed to the question and answers round. I'll display the questions on screen, and all the panelists are open to answering any question.
So, what is the effect of the higher DC loading on the inverter electronics component, and it is prone any failure? Amitji, right? Can you
Yeah.
share of your
So yeah. So one of the direct. So what exactly happens that as
yeah
you
what
increase.
yeah you have already told that it can go up to 50%.
Yeah.
I mean on the DC
Yeah.
side
So
loading.
typically, I remember that initially it started as low as maybe 10% to 15% was the loading. Today,
Right.
50% loading is a norm, and some of the inverter even allow higher than that, even up to 165% loading also they allow. What impact does it have is that first of all the inverter should be capable to handle that much of DC load, because higher DC load means higher current
Current.
is entering into the inverter, so it should be capable of that. So in terms of the design of the inverter, in terms of the fuse and other things, it should be compatible with respect to the whatever is the maximum loading can be allowed. As a good practice, typically each manufacturer allow a typical overloading, but in cases if you give your specific case, they allow even higher than that also. They check that whether that much of overloading is allowed or not, and then they give a project specific approval also, that yes, it is possible to load inverter even higher than their specified DCAC ratios.
Okay. So in case of from the design perspectives, Amitji, so is it sometimes to validate from the third party, engineering organizations or something?
Yeah, it is. Yeah, it's always good to get the validation through the consultant, that yes, this is the inverter, this is what is the rating, and then is it safe to go for that particular thing. So some of the reputed consultants take up this particular thing, but these days most of the developers have built a lot of in-house expertise, and many times we ourselves can run various simulations. We'll get the OND file from the inverter manufacturer, we run our own simulations, and we try to find out that at that loading, two things we have to check: that what is the clipping we are getting, because as we increase more and more DC-AC ratio, there will be more clipping. So am I wasting too much of energy? That is one part of it. And second thing is the confirmation from the system point of view, that whether the inverter is technically capable to take that much of overloading with respect to the system design.
True. So sometimes from the the lender's point of view, these are also already mandatory. That the third party
Yes.
validations is required. Right? Thank you.
Yes.
So why central inverter is much more efficient from the string inverter in the utility scale project? Right? Uh, uh, Rajesh, can you
Yeah.
share of your the process? Right.
Right, sir. So actually, here some of the like the statement is little bit contradictory, but in the response time, we can say basically central inverter. What I observe basically when you have like kind of 1,000 megawatt of project, and in
Okay.
1,000 megawatt project you have to deal with 1,000 inverter, central inverter 1 megawatt, or
True. True.
either you have to deal with 4,000 inverter which are
True.
300 kilowatt. So
Right.
the n number of nodes are there, and you are at the point of connection, at the metering point, you are maybe something about 3 kilometer away or 2.5 kilometer away. So
Mm-hmm.
the response time in case of string inverter in the center inverter will be better.
Mm-hmm.
That because the recently one case happened where grid was wanted to have reactive power in the grid. Suddenly there was the failure, short circuit, and due to short circuit the grid voltage dropped, and LVRT function enabled. The string inverters were down their reactive power, but on the same time, as per NRLDC, they were not able to feed the power. So they should also keep some memory. They should also keep some recording, or either the trained, because in inverter also required some of the, of course there is a cost, but they should also in the inverter level they can record data, and in the PQ meter level even the DR recording is there, and switchyard level there is a recording there. So both should get synchronized. So basically central inverter can be better in the response time, but other aspects, mismatch and MPPT, so string inverter is better as well.
Okay. Thank you. Next question, Saksi.
Sir, this is all that we had today for questions. I'd like to extend my appreciation and thanks to all our esteemed panelists for this exhilarating session, and especially special thanks to you, sir, for superbly moderating the session. We would like to also extend our gratitude to everyone for investing their valuable time and support for the event. I hope the key takeaways from the session will be instrumental in paving the way for sustainability. We promise to be back with more exciting sessions. Till then, thank you so much and good evening to all of you.
Okay. Thank you, Solar Crotas. Thank you, all the
Thank you.
speakers, for sharing their views. And it was an excellent webinar. Though I joined late, there was a little technical difficulties. But finally, I believe Rajesh and Ahmed ji and Atul and then Syed, I think, and everybody we have enjoyed. Thank you very much. Thank
Thank
you.
you.
Bye bye.
Thank you, sir.
Have a good
Thank
day. Bye
you.
bye.
Thank you, sir, for conducting the session in a very, very professional way and in a very time bound way.
Right.
Okay. Thank you.
Okay.
Thank you, sir. Thank
Yes,
you.
sir. Thank you so much for
Thank you.
moderating the session perfectly.
Thank
And
you. Thank
special
you.
thanks to Mr. Rajesh